In this video, we are going to do 18.01 grocery. All right, so I have the file opened up in Racket. So notice how the data definition steps, some of them are already done. We're going to do the template step. I recommend you guys pause the video and look through all the steps that are already done, right? Defining of these grocery structure and what it is and etc. and the template here. All right, anywho, let's just get started with problem A. Finish the template for list of grocery, right? So here's the list of grocery template. It consumes a list of grocery, and we don't know what it'll produce yet because this is just a template. And here's the to-do comment right here, right? So pause the video and try to do the grocery template on your own. Go over spoilers in 3, 2, and 1. All right, I'm going to assume that you guys took a good swing at it. So now let's go over it together. So we're just laying out a good scaffold here for list of groceries. So define list grocery temp consumes a list of groceries. So we'll call it grc-ls, right? That's one name. You can name it something else, but you know, I'm just going to take the 3 most important letters, right? And then just put -ls like so. All right. So it consumes a list of groceries, and then a list of groceries is going to be a one of, right? So one of means that we need a cond here, and we do something when the case is empty, right? So what happens if the list of groceries is empty? Well, we want to do something. And otherwise, want to do some operation on the first of the grocery list, and then the rest of the grocery list, which needs to be wrapped around a recursive call to the function, because we're dealing with self-reference, like so. All right, so what are we going to do with this first grocery list, right? This grocery itself, right? This here. Well, since this is a non-standard type with Racket, right? As I explained in the previous video, you have to wrap this around the helper function, preferably referring to the template of the grocery template, right? Because we're going to need to pick apart the fields and maybe do some operations on it. So we're going to wrap this around a grocery temp. All right. All right. And that is some pretty good scaffolding that we're going to use for problems B, C, and etc. All right. So that is problem A done. Now let's move on to problem B. So problem B says, design a function total-prices that consumes a list of grocery and produces the total price of all groceries in the list. All right. So pause the video and try to work through the function steps of total prices. I'm going to go with spoilers in 3, 2, and 1. All right. I'm assuming that you guys took a good swing at it. So now let's go over it together. So first comes the signature. So total prices. Prices consumes a list of grocery. All right. According to this problem statement here. And produces the total price of all the groceries in the list, right? So the total prices are represented by numbers, so that's what we're going to produce. And next is the purpose statement here. So produce the total price of all the groceries in the given list. All right? All right, the sum total price is probably more accurate. The sum total price of all the groceries in the given list. All right, signature, purpose, let's stub this out. Define total prices. All right, grc-ls is going to be the list of groceries. We have to produce a number at the end of the day. So just as 0 as the dummy value. All right, next, let's do the test here, right? So what happens if the list is empty? Well, we just produce 0 because you're not buying anything, right? What happens if, you know, we have some things in this list, right? So I'm going to copy down the data definitions above here, right? The example data definitions here, because we're going to need to reference it, and I want to scroll up and down all the time. All right. So what happens if we're buying, where is it? Oh, I pasted it to the wrong problem block, my bad. Problem B, that's what we're on. All right, so here, so we're still running examples. So what happens if, you know, we're given the list chips and a tomato, right? So chips cost $1 and then tomatoes cost $1, right? So this should produce 2, all right? So hopefully you get a picture of what this function does. Let's do another example here. Total prices, let's do, you know, list cheese, right? So that's that variable here. And then we'll do another one, lettuce. All right, so let's say 3 plus 2 is 5. So this should produce 5, right? So 3 plus 2 is 5. And that is a good enough set of examples, right? You can write this more explicitly by saying, you know, plus 32, right? It's still gonna produce the same, right? All right, so that's a good set of examples. Let's just run, and we get some differs here, but that's fine, right? 0 differs from 2, 0 differs from 5, That's just mismatches, nothing wrong with the examples themselves. All right, now let's grab a template that consumes a list of groceries because we can use that as a starting baseline here. Copy that down, rename this total prices. All right, now really pause the video. Hopefully this should be all the mental scaffolding needed for total prices. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So the first test here, wait, what happens when the list is empty? Well, we produce 0. So that's what we're gonna do, like so. Now the other case, right? So we want to produce a number and we're likely going to need to add numbers up, right? Because we're trying to produce the sum total price of all the groceries in the given list, right? So I have to keep adding all the grocery dollars, right? How much they cost. So we're gonna need a plus here, right? So grocery dash temp, right? So this temp is going to be the price, right? Dash price. We see this define struct over here, right? There's going to be a dash price function that gets the price out of these structures, right? So that's what this is going to do. So problem B, right? Dash price. All right. So we're going to want to take the price out, right? And then add it to the rest of total prices, which will get the total prices out of the other list, right? Of any element list. So this can be 3 long, 4 long, 5 long, etc. It's going to keep looking through the rest of the list, right? So get the grocery price out and add it with the other grocery prices, all right? So this should pass all those tests. I'm going to run this function. And likewise, we see that all 3 tests do pass. All right. Now let's move on to problem C. So problem C says, design a function filter-price that consumes a list of grocery and a price and produces all groceries equal to or under the given price, right? So equal to or under. It's important to remember, all right? So pause the video and try to work through the function steps for filter price. I'm gonna go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it. So now let's go over it together. So signature filter-price consumes a list of groceries, all right? So that's gonna be the first argument, and a price. So it's gonna be a 2-argument function, and produces all groceries equal to or under the given price, right? So produce all groceries equal to or under the given price. All groceries, right? So there's going to be a set of groceries that are going to be under the given price, right? Groceries. All right. So signature purpose, let's fill out the purpose. So the purpose is to produce all groceries equal to or under the given price, right? That comes straight out of the problem statement here. But you know, this time we got lucky. Other problems in the future will be a bit more vague. All right. Signature purpose. Let's stub this out. So define filter price. It's gonna have a grocery list, and then also the price itself, right? So we're gonna say threshold. It's gonna be the name of the second argument, and this has to produce a list of groceries. So we'll just produce empty, right? Because that is a list of groceries. All right. So that's the stub. Let's write some examples here. So check expect. So filter price. All right. So let's do something like list. Let's do the empty list first, right? And then the threshold, we'll say is $2, right? Well, nothing is under $2 because there's nothing in the given groceries list, all right? Let's do another example here. Filter price. All right, let's pass in all groceries, right? So this here, in fact, I'm gonna copy and paste this down below here because we're gonna need it, and I don't wanna keep scrolling up and down, right? So all groceries is defined all the way above, but this is just copy and pasted here, right? So all groceries. So I want all groceries under $2, right? So this, right, equal to or under $2, right? So it's gonna be these 3, right? So these 3 are all under $2, right? So the tomato, right? The lettuce, not the lettuce, the tomato, wait, no, the lettuce, yeah, it's 2.0. I didn't even know what I was looking at. All right, so the tomato, the lettuce, and the chips, right? But the order is important here, right? Because the order is gonna it's gonna iterate in this order, left to right. So we're gonna have to get the order right here for this test, right? But nonetheless, right, this should produce all groceries under $2, right? So is the tomato under $2? Yes, it's $1. So it's gonna be tomatoes. It's gonna be first, right? And then lettuce is lettuce under $2. Lettuce is $2, right? It's equal to $2, which is what this function, wants, right? All groceries equal to or under $2, right? So that is also going to be filtered in. So lettuce. All right. What else? All right, so let's lettuce, cheese. Cheese is $3. So that's not going to be included. Chips is $1, right? And this 1, 2, 5, 4, that's the stock. All right. So chips is also going to be included here. All right. So filter price of all groceries that are under $2, equal to or under $2, right? Should produce the list tomato, lettuce, and chips. All right. Let's do one more example. Why not? Right? Check, expect, filter, price, all groceries. Let's say $1, right? So this should produce the list, right? Is tomatoes under $1? Yeah, it is exactly $1. It's equal to or under $1. So that goes in the list. What about lettuce? Lettuce is $2. So that's not going to be in the list. Cheese is $3 and chips is $1, right? It's equal to or under 1. So produce the list tomatoes and chips given all the groceries in the list. All right. So that's a good amount of tests. Let's just run this. So empty differs from the list that we're supposed to produce. That's fine. All right. Just mismatches, no typos and anything. All right. So let's grab a template that consumes a list of grocery that we wrote for problem A and use the scaffold. All right. And it'll get us a good portion of the way there, right? So we got to rename this function. It's going to be filter price, this template to filter price. Consumes 2 arguments, a list of groceries and a number, right? So this time we named it threshold, right? I'm going to delete the stub now because we don't really need it. All right. So threshold, and yeah, this is a good enough starting point. All right. So now really pause the video. Hopefully this should be all the mental scaffolding needed to solve for filter prices. Pause the video and try to work through it on your own. I'm going to go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So what did we do in the empty case? Well, we just produced the empty list, right? Because there are no groceries to filter that are under $2, right? There's no groceries at all. All right, now comes the harder part, all right? So sometimes, you know, for this test here, right? Sometimes some of the groceries are equal or under to $2, and sometimes they're not, right? So we're going to need an if here, right? And the condition is going to be whether it's going to be less than the threshold, all right? The given grocery itself. So we're going to need the grocery price itself. So I'm going to copy and paste this here, right? We're going to need the grocery price, right? So if the price is equal to or lower than the threshold, then we want to do something, right? Well, what do you want to do? We want to include it into the resulting list, right? So what we're going to need to do is we don't really need this temp here. We can delete that. So this is going to be the grocery that is going to be under the given threshold, equal to or under. So what we need to do is we need to produce a list, right? So that's what we're going to do. We're going to have to cons this onto the rest of the list, right? Because there are more elements, there are more groceries to go through, right? So we have to call the recursive function, we have to call ourselves on the rest of the list, which we'll assume will work for, you know, however long this list will be, right? In this case, it's 4 elements long. This can be like 10, 100 elements long, and it'll work, right? We're just going to assume that it works. All right, likewise, otherwise, right? So this is the true branch. This is going to be the false branch over here. Otherwise, we're just going to call filter prices on the rest of the list without this consing here, right? So this does the consing and this false list, right? If it's not under or equal, if it's not equal or under the threshold, then we just keep going, right? We don't want to include it. And this should pass all these tests. Threshold is not defined. Did I spell it wrong? T-H-R, I should add an R here. Threshold, not T-H-E-S hold. Threshold. Ugh. Threshold, all right? So, like so. So, I forgot that threshold needs 2 arguments. That's fine. And another 2 arguments here. That was a misspelling earlier, but this time it was 2 arguments. All right, so all 6 tests do pass, and that is the answer for filter price. All right, so now let's move on to problem D. So problem D says, design a function restock that consumes a list of grocery and a number and produces the list of groceries with the stocks increased by the given number. All right, so pause the video and try to work through problem D, restock on your own. I'm going to go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over together. First comes the signature. Restock consumes a list of grocery according to the problem statement. Also a number, right? So it consumes a list of grocery and a number. So it's going to be a 2-argument function. And produces the list of groceries, right? So it has to produce a list of groceries. List of grocery. All right, with the stocks increased by the given number. All right, so signature stub, right? We can write the purpose statement here. Signature purpose, I mean. So produces the list of groceries, produces the given list of groceries, with the stock increased by the given stock. All right, and this is going to be the given stock. All right, so signature purpose, let's stub this out. Define restock consumes a list of grocery, right? So that's going to be grc-ls. And then the number, what should we name this number? I can name this, add stock, maybe. Maybe I'll just call it inc for increments, right? Increments. You can call it whatever you want though, whatever makes sense to you. But that's what I'm gonna call it. And it produces a list of groceries, so we can use empty as a dummy stub value to run against some examples here. So we're gonna restock. So what happens when the list is empty, right? And we want to, I don't know, we can add whatever, we can add 100 here, it doesn't matter, right? Because there are no groceries here in this list. Well, we just produce the empty list, right? There's nothing to restock, right? Otherwise, right, we have to do other tests here. I'm gonna copy and paste the examples here, so we don't have to keep scrolling up. All right, an example of groceries, all right? So check expect, restock. All right, so list, let's say chips, right? And we want to add, let's say we're ordering 5, right? Why not 5? Well, we want to restock this stock of groceries, list of groceries, adding 5 to the stock, right? So this is the stock right here, and this is the price. So we're going to add 5 to 1, right? So we should produce a list where the chips stock, right? This is going to be the stock field, is increased by the increment here, 5, right? This parameter here, right? So it should be 6. All right, let's do a 2-argument test here, 2list test. So I'm going to do check expect. Restock, let's do list cheese, and then let's say tomato, all right? And then we're going to add, I don't know, 2, right? To the cheese and tomato stocks, right? So if we restock the list of groceries with cheese and tomatoes 2, right? Well, we want to produce a list where cheese, so here's cheese, right? And here is tomato. Here's tomato, like so. All right, their stocks are going to be increased by this given stock right here. So cheese is going to have its stock increased by 2. So it's going to be 4 plus 2, which is going to be 6. And then tomato is going to be increased by 2 also. So that is going to be their updated stocks. All right, anywho, let's just run our stub against the test here. And we just get mismatches of the list that we're supposed to produce, right? So like so. Anywho, that is almost done. We're almost there. We're gonna come out the stub here. And this restock consumes a list of groceries. So we can grab the template that we did all the way back in problem A. That will give us a good foundation over here, like so. And we're gonna rename this restock. This function consumes 2 arguments, right? The increment itself, right? The number that we're gonna increase the stock by, like so. All right. So now really pause the video. Hopefully this should be all the mental scaffolding needed for restock. I'm gonna go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So what do we do in the empty case? Well, if we're given an empty list of groceries, right? Just produce an empty list of groceries, right? Because we can't really increase the stock, of an empty list of groceries. Otherwise, right, what do? Well, we still have to produce a list at the end of the day, according to the signature here. So this ... is going to be a cons, all right? Cons, and then what do we want to do with the grocery itself, right? Well, we probably want to pass it to something that can increase the stock, right? So chips, right? Let's say chips want to increase the stock by 5, right? So, yeah. So this is going to be a function that increases the stock. So this is going to be another task, right? That we're going to hand it off to another function to do instead of doing it here. So you could do it here if you want, right? This can be make grocery and you can take apart the fields, but it's going to end up pretty hairy. So I'm just going to pass it to another function called upstock. And we pass in the stock we want to increase it by, which is given here, like so. And then what do we want to do? Well, we want to cons it on to the rest of the list. We want to increase the stock of the rest of the list, right? Like so, which we'll assume will follow the purpose statement here, right? So in case of cheese, right, we're going to increase the stock for cheese, but we have to restock all the other items like tomatoes, right? You have to increase the stock by 2. So restock the rest of the list as well and keep going through the rest of the list. Anywho, we just thought of this at a high level, right? Increase the stock of the given grocery in the list, but this function does not exist yet. So let's just run through the steps for upstock. Upstock, right? Consumes a grocery, right? Why? Because first of grocery -ls is a grocery itself, and also a number, right? Because that's the number that we're going to increase the stock by. And we have to produce a grocery, right? Because this is going to produce a list of groceries, and we're using it in this function, right, of restock. So list, not list of grocery, right, like so. So signature, purpose, all right. So I recommend you pause it and try to work through upstock on your own. Spoilers in 3, 2, and 1. So purpose is produce the given grocery, but with the stock increase with the given number. All right, stub this out. So upstock, given the groceries, we'll call it GRC, and then the stock that we want to increase it by. And we still have to produce a grocery, right, at the end of the day. So let's just do a dummy grocery, right? Let's just take any of these. It doesn't really matter, right? All right, so that's stubbing it out so that we can run against some tests here. We really only need one test, right? So let's say the grocery is chips, right? So let's say chips is, actually I'm just gonna grab it up here. Chips, all right, so chips is the name of the grocery. This is the price, and this is the stock, right? So we want to increase it by 1, right? So upstock has 2 arguments. This is the first argument, this is the second argument. So we have to produce the grocery with the stock increased by a given number. So make grocery, the name stays the same, still gonna be chips. The cost stays the same, still gonna be $1. And then this one is going to be a 2 now because we want to increase it by 1. All right. So let's do another example. Why not? All right, let's do tomato this time. So actually, let's do lettuce. Why not? Lettuce. All right. You don't really have to do more examples. It's kind of really straightforward as to what this does. But for fun, right? So the lettuce already has a stock of 5, right? But we're increasing it by, let's say, 2 this time. Well, this time we want to produce a lettuce, but with the stock increased by 5 plus 2, right? 5, the original, and then 2 is the one we want to increase it by. All right, so that's a good amount of tests done, right? So we got all failing tests, but looks like there are no typos or anything. So now let's grab something, the template of the grocery here, and use that as a scaffold right over here. It's going to be a good baseline to work off of. Rename this to upstock. This takes in 2 arguments. Upstock takes in 2 arguments, right? The increase in stock that we want to do. All right, so now really pause the video. Hopefully this should be all the scaffolding needed for upstock. I'm going to go over spoilers in 3, 2, and 1. All right, I'm assuming that you took a good swing at it. So now let's go over it together. So we have to produce a grocery at the end of the day. And the only way you can do that is with make grocery. All right. Oh, and likewise, I just realized, like, for the stub here, right, you can just pass in GRC. You can just spit out the grocery that you're given as the, stub here, right? I just realized that. Anywho, back to the function definition here, right? We just want to increase the stock by what we're given here, right? So just add the increase in stock to the given stock. And that should pass this test, and by virtue, finish up the restock function as well. And we see that all 11 tests do pass. All right. So that looks pretty good. Control I to reindent our code, maybe look over it and try to simplify some things. In this case, I think it's pretty good. All right, and hand it in to hand in and make sure that you pass all the greater side tests. All right, and that is about it for this video, and I will catch you in the next one.